Last week we looked at exponential functions. This week we're going to look at its inverse, which is log functions. So an exponential function is seen here in the red. It's something that grows really, really quickly. Notice how it just skyrockets up there. The opposite of something growing really fast is something that grows really slow. So looking at our log function in the blue here, I notice I'm going from 0 to 2 in, wow. How long does it take me to get to 2? Well, it takes you 100 units to get to 2. It almost looks like there's a horizontal asymptote, but there's not. It will eventually go all the way up to infinity. It's just going to take its time to get there. Where my exponential function has a horizontal asymptote, the opposite of having a horizontal is having a vertical. So logs do have a vertical asymptote, as you see here. My log will never equal 0. As they get closer and closer to it, notice how, oh, it looked like it was touching it, but it's not. That's because, as we see with my exponent, I have no negative y values. The opposite of having no negative y values is having no negative x values. So your log, there's no way you can get a negative x. If I go into my calculator and do log of a negative number, it gives me an error. You cannot do that. The reason why is because I can't take a number and raise it to a power and get a negative out of that. If I raise it to a positive power, I get a positive number. If I raise it to 0, I get 1. Anything to the power of 0 is 1. And if I raise it to any negative number, it's still a positive number. It's just a really small positive number. So you cannot get any negative x value. You cannot plug in any negative x value into log. It'll crash, as you see here with my graph. What is logs? Basically, logs is answering the question, how many of one number do we multiply to get another number? For example, how many 2's do we multiply to get 8? 1, 2, and 3. 2 times 2 times 2 equals what? 8. So I get 3 2's will give me 8. Write it here. Log base 2 of 8. How many of 2's do I multiply together to get 8? The answer is 3. So here's the notation in terms of logs. How many of this number do you multiply to get that number? The big takeaway for today is, since we've been talking about exponentials and logs, let's look at how to convert between exponentials and logs. So, the standard format for my exponential function is a to the x power equals x. I have some number, I'm raising it to some power, and that equals another number. Its format for log is log with the base a of y equals x. Now notice, what we call the base with the exponent is the same thing what we call the base of the log. The base for the log is that little number down there on the bottom. And see how my log equals a number. That number will be your exponent. So if you're going to remember anything from today, remember this. Logs equal your exponent. That power. Logs equals power. For example, I want to convert 2 to the 5th power equals 32. So I have a base of 2, so it's log base 2. It equals, my power is 5, so this log will equal 5, and then my exponent equals 32. Basically, the only other option left to put it in there is right here. Log base 2 of 32 equals 5. How many 2's do I multiply together to get 32? 5 2's multiplied 5 times will equal 32. So one more time, what log is representing is that. Equals 5 2's. I'm more of a visual person, so to visualize this, I like to use this method. So I have 3 as my base squared equals 9. If I want to turn this into a log, I take my base, drop it directly down into my log base, so log base 3. Then I look at my exponent, so the next number, I know my log equals that exponent, so equals 2. And then the only other slot missing is the only number I didn't use yet, which is 9. Bam, goes right there. Log base 3 of 9 equals 2. So 3 times how many times is 9? 3 times 2 threes. 3 times 3 is 9. So there's our conversion. By the end of the day, you should be able to do this in your sleep. Conversions is going to become very important for the remainder of us talking about logs. So as I see here, let's look at a couple examples. Log base 7 of 49 equals 2. Looking at this here, it makes sense. How many 7s do I multiply to get 49? 7 times 7, 2. And this one, log base 2 of 32 equals 5. How many 2s do I multiply to get 32? Well, we've kind of already seen it. 5 2s gives us 32. But my goal here is to convert this into an exponential form. So let me write the formula. So it is log base b of y equals x to the b of x equals y. Now they used, I think I just used different variables from before. I think this was a. Notice it's just interchangeable. I like to use b because it stands for base. So let me identify what my variables are. So my b variable, my base is 7. So b equals 7. My y value is 49. And my x value is 2. So b is 7, y is 49, x is 2. Now come over here and just plug it into your exponent form. So b is 7 to the x power 2 equals y, which is 49. That makes sense. 7 squared does equal 49. So there's my conversion. Log base 7 of 49 equals 2 converts into 7 squared equals 49. Again, I want you to remember, your log will equal your exponent. So let's convert log base 2 of 32 equals 5. I like to do it like this. This gets dropped directly down to 2. That's my base. I'm going to raise my base to some power. What number do you think that's going to be?
5.
It's what your log equals. 5. And that equals, well, what number have I not used? That equals 32. That's how I like to convert. Bring the base down, raise it to the power of what my log equals, and then just put in the other number. 32. 2 to the 5th power equals 32. So now you give it a try. Convert these into exponential forms. Log base 8 of 2 equals 1/3, and log base 9 of 27 equals 3/2. 8. Very good. That comes directly down. 8. It's being raised to what power? 1/3. And it equals 2. Haven't used 2. There's my exponent form. Number 6. What's my base? 9 raised to the power of 3 over 2 equals 27. Very good. There's my exponential form. Now let's go the opposite direction. So I have an exponent and I want to change it to a log. So I write log. Now what's going to be my base? It's real easy. The first number you want to put down is your base log, which is the first number you run into in your exponent. It's 5. Now I want to jump to my log equals what? What does your log equal? I've said that 2. I say it time and time again. Your log equals the exponent. My exponent in this case is 2. And what number did I not use? 25. So log base 5 of 25 equals 2. Now for this one, log with what base? First number we want to put down is the first number we run into, 8. Next, I want to look at the exponent because that's what my log equals. So it equals 0. And then what number did I not use? 1. Log base 8 of 1 equals 0. So we know any number raised to the power of 0 is 1. Likewise, any log, when I try to find 8, how many times you multiply 8 to get 1? 0 times. Multiplying 8 0 times just gives you a 1. Because nothing's there. So the placeholder is 1. So let me give you these a try. Let me give you a minute. Convert these into logs. All right. Log base 5. Well, what's my base? 3. This will equal what? -4, my exponent. So the only other option to put in my hole here is 1 over 81. Log base 3 of 1/81th equals -4. Next, log with a base of 12 equals 1 over 2, my power. And now the only other number on the left, put in my only spot left. So the log base 12 of 2 times square root of 3 equals 1/2. Now let me introduce some formalities. I have said time and time again that mathematicians are lazy. When we have x, we usually don't write x to the 1 power, right? We keep that 1 cut off. Too much work just to write the extra 1. Likewise, when I take the square root of x, I usually don't write that 2. You know, if you don't see any roots, it's assumed that that root is going to be a 2. Now, when we're dealing with logs, mathematicians work so much with log base 10 that when you don't see it out, or don't see a base, it's assumed that that base is going to be a 10. So what they cut off with logs is the number 10. Note, very important, this is the log that's in your calculator. So if you look in your calculator and you click on this log, that log is only going to be base 10. I hope you remember that. Because what that means is we are rarely going to be using this button here. We're going to work with a lot more different bases than just 10. So log base 10 of 100 is 2. That makes sense. How many times do I multiply 10 to get 100? Twice. So this log on the calculator is only talking about base 10 when you cut it off. Now there's another type of log that's used very often, and that is log with a base of e. We saw e with exponents when we dealt with continuous interest, something that gets compounded continuously, a very large number. We have some kind of perfect curve here. That got used so much that they decided not to write 4 letters, but instead shorten it to just 2 letters. This represents ln, natural log. Now note, you can see how old this is already, because natural log is written from right to left. So this is well before America was founded, well before this continent was founded. This is when they introduced ln. So log base e is what this ln means. And it happens to be right below your log base 10. ln is right here. So, if I were to ask you to convert ln x equals, let's just say 1, to exponential form, what's going to be my base? What's the base of ln of x? E, right? So this should be some base e raised to the power of 1 equals x. So on the homework, you will see convert ln's into exponential forms. Don't get confused. Just know that this is a base e. ln of x represents base e. when you convert it. You're raising e to some power. Which hopefully will remind you, because if you look in the calculator, what do you see that's above ln? E of x. Second e of x. So I have my log function, and on the top of that, it's inverse, e of x. I have my log base 10, and on top of that is its inverse, 10 of x. They were nice enough to put that on the calculator for us. Hopefully that'll help remind you what those represent. And lastly, I'm going to introduce a old school, kind of outdated concept. I wouldn't be surprised if they take this out of the whole curriculum completely, because you have an updated calculator. If I were to ask you to calculate log base, let's say 4 of 5, how could you do that if your calculator only had base 10? When I was in high school, we only had base 10. So in the early 2000s, that's the only log we could work with. So I had to use what's called a change of base formula, which takes the log base b of a is equivalent to the log base log base 10 of a over the log base 10 of b. So you have to punch in log of a over log of b. So to calculate what this equals to, got to use the change of base formula. So log base 10 of a, 5, divided by log base 10 of my base, which is 4. 1.16. 1.16 roughly. Good news is, like I mentioned, this is out of date. Because now TI was smart enough to put in log base in your calculator. So pay attention. You're not going to use this log base. You don't have to. What you're going to use instead is alpha window. Alpha window. Go take you to the functions options. And notice, what does number 5 say? Log base. That gives you the option to put in any base you want. So now, if I want to find what is log base 4 of 5, put in 4 for my base, 5 for my log, and hit enter. Same thing, right? That's how you're going to calculate your logs. You're going to use that log base. So instead of this, you want to go to alpha, window, choose the 5th option, log base. Put this in your notes, circle it, highlight it, star it, whatever it takes to help you remember. This is where you're going to be calculating your logs, because we do not work in a perfect world where it's all going to be log base 10. We're going to be working with all different types of log bases. Alpha window, 5. 3 buttons to push, and then you're good to go. So when I want to calculate these, log base 5 of 34. Don't have to worry about the change of base. I want to do alpha window. Number 5, log base 5 of 34 equals 2.191. 2.191. Now I want everybody, I want to make sure everybody knows how to do this. In your calculator. Find log base 2 of 98. Alpha window. Everybody needs to figure this out. Don't want you to ask me on the test.
6.6.
That sounds about right. So let's see. Alpha window, number 5, log base 2 of 98, 6.61, 47, whatever. 6.61.